Okay, this is a very tough sum, but doable. So there are three fair six-sided dice. Each die has two green faces, two yellow faces, and two red faces. All three dice are rolled together. Find the probability of rolling exactly one red face. So the number of dice are 3, so your n number of trials are 3. Probability of success. Now there are 2 on 6. My success is getting a red face. So there are 2 red faces out of 6 faces. 2 on 6. Correct? Number of trials are 3, we can say. So exactly one red face. So probability x is equal to 1. Apply BPD. You will get the answer. Find the probability of rolling 2 or more red faces. If you want 2 or more red faces, you have to do BCD. Probability x is greater than or equal to 2. Correct? Your n is this, your p is 1/3, and you'll get the answer. Ted plays a game using these dice. The rules are, having a turn means rolling all 3 dice. You have to roll all 3 dice together. He wins $10 for each green face rolled and adds this to his winning. After a turn, Ted can either end the game and keep his winnings, or have another turn and try to increase his winnings. If 2 or more red faces are rolled in a turn, all the winnings are lost and the game ends. Now this is the crucial part. This is the main part that you need to remember. If 2 or more red faces are rolled in a turn, all the earnings are lost. Show that after a turn, the probability that Ted adds exactly $10. Now when does he add $10? He adds $10 for each green face. So for each green face he adds $10. Plus, he'll add $10 only if he does not get 2 or more red. Now, this is very important. So, you have to take both these conditions together. So, what I did is, I actually listed it. So, I want $10 for one green. So, I can get the first green, yellow, red, green, red, yellow. Then, green, yellow, yellow. So, this one underline is getting one green. Now you obviously won't get green, red, red because then you're losing all the winnings. Second green, yellow, green, red, yellow, green in between basically with all the possibilities. Yellow, green, yellow. So these two underlines are the second being green, and this is the third being green. So third being green will be 1, 2, 3, third green, third green, third green. So that means getting a green is 1/3, getting a yellow is 1/3, getting a red is 1/3. And this you multiply by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how you get 1/3. Now, the random variable D represents how much is added to his winnings after a turn. So this they've given it a distribution. The following table shows the distribution of D, where $W represents as winnings in games so far. So winning in games so far, now this minus W means is losing that. So whatever winnings he got so far, he is losing that. When will he lose it? When 2 red faces are thrown. Now when does that happen? 2 red faces are thrown. What is the probability of that happening? So from this table, minus W represents all the winnings are lost. This happens when 2 or more red faces are rolled, which is A part 2 here, this part. 2 or more red faces. This is 0.259, that's 7 over 29. So this is my 7 over 20. No, 0.259 you can put it. That's how you get your x. Now to get your y, the sum of all this should be equal to 1. So you do sum of all this is equal to 1 and you'll get a value of y. Ted will always have another turn if he expects to increase his winnings. Find the least value of w for which Ted should end the game instead of having another turn. So what is the least value of w? So what you do is I'll put minus w. I put in the corresponding probabilities. I got the value of x and y. I'll put them here. And my expected win is this. Now my expected win should be greater than 0. Means I want to take some winning. Correct? So that means so you solve for w. So my expected winning is greater than 40. So it's 40 because you'll obviously either get 10, 20, 30, 40, you know. So when you get when you get $40, that's the least value of W. Correct? So that means you can take another chance till you get 40. But once you get 40, it's better that you take this $40 and move out. rather than trying another try, otherwise you lose all those $40.